All right, so sp3 hybridization, let's start off here. So we're thinking 4 things, 4 orbitals must be sp3. And so remember, sp3, just as the name implies, we're going to hybridize one s orbital with 3 p orbitals. Notice here the 1s and the 3p orbitals, I'm referring to how many orbitals there are. I'm not talking about n, so this s could be a 2s, a 3s, or 4s. I'm just saying that there's one of them. And so all of this goes back to the fact that electrons can behave as waves, and in this case, 3-dimensional waves. So remember, waves, if they are kind of in sync, they're going to constructively interfere, and so you'll combine the 2 waves into a bigger wave. If the waves are out of phase with one another, something like this, right, they're going to cancel each other out, and then you kind of destroy your wave. And so let's take a look at that in terms of orbitals. All right, so this picture does a pretty good job with this. Remember, the color here is the phase, whether it's up or down. So you can see here when we have, let's take a look at this one and this one, we have blue and blue, so they're in phase, and so they're going to constructively interfere to make a bigger one. And then if you think about this blue and then this red down here, they're out of phase. And so this part of the orbital is going to get smaller. And so if you combine these two, what you end up is this orbital right here. I don't know why they didn't put them in order, but they didn't. Anyways, and so you hybridize the s orbital with all of the p orbitals, and what you end up is this final structure down here. And so you can see it gives the same result as Vesper. So sp3 hybridization is the same thing as tetrahedral. Right, so it's the same thing as Vesper. Let's take a look at it in terms of these orbitals and their placement in energy, right? So we have the ns orbital, and then we have 3 of the np orbitals, and all 3 of these are going to mix and hybridize into 4 sp3 orbitals. Remember, the number of orbitals needs to stay the same. So 4 sp3 orbitals. And so if you take a look at carbon and hydrogen, carbon's going to hybridize to these sp3 orbitals, so 1, 2, 3, 4. And think about carbon has 4 electrons, so 1, 2, 3, 4. And then hydrogen just has 1 electron, just its 1s electron. And so you can see that carbon has 4 half-filled orbitals, hydrogen has 1, and so it predicts a 4 bond situation and a tetrahedral shape. And so the kind of the same thing we said with Lewis structures and Vesper. And same thing with something like nitrogen and hydrogen. Nitrogen will also adapt an sp3 hybridization. But now nitrogen has 5 electrons, and so now it only has 3 half-filled orbitals. And so if you think about hydrogen, just has 1 half-filled orbital, so you'll need 3 hydrogens. So it predicts 3 bonds and then 1 lone pair, which is exactly what it looks like, right? If you drew the Vesper structure right there. So overall, sp3 hybridization doesn't really add too much to the conversation when we're talking about this, because it's still the same tetrahedral shape. So it didn't really give us any more info than Lewis structures plus Vesper did. In this next section, we'll see how it gives us an additional piece of information.